Good morning, everyone, and a warm welcome to the technical workshop on oceanographic sensors and systems development at NIOT. We are delighted and honored to have distinguished guests and experts in the field of oceanographic sensors and systems with us today. I now invite our esteemed dignitaries to the dais. Our chief guest, Dr. P. Hanumanta Rao, Director General Samir. May I please request you, sir, to come on the dais? Our, our beloved Director, Professor R. Balaji. Group Head Marine Sensor System, Sri M. Sankar sir. Kindly come on the dash, sir. My boss, Group Head Ocean Electronics, Sri S. Muthukumar Vel, sir. Group Head Ocean Observation System, Mr. Arul Mutaya, sir. Kindly grace the dais. I request our Director NIOT to welcome the chief guest with a bouquet. Thank you very much, sir. To mark the beginning of the important event, I now request our dignitaries to join in traditional lamp lighting of the lamp, symbolizing knowledge, wisdom, and enlightenment. Please, sir. Thank you. Thank you, respected dignitaries. To commence the workshop on an auspicious note, let us all rise for the invocation. I request Sri S. Vasanti ma'am to kindly.
వినాయక నిన్ను వినా బ్రోచుటకు వినాయక నిన్ను వినా బ్రోచుటకు వినాయక నిన్ను వినా బ్రోచుటకు వేరే వరురా విఘ్నరాజ వినాయక నిన్ను వినా బ్రోచుటకు వేరెవరురా विघ्नराज विनायका अनाथ रक्षका अनाथ रक्षका अनाथ रक्षक नीवे गदा अनाथ रक्षक नीवे गदा आदरींसु ननु ब्रोव राज आदरींसु ननु ब्रोव రాధవినాయకా నిన్ను వినా బ్రోచుటకు వేరు వరిరా విఘ్నరాజ వినాయకా सरसीरुहारु नायक चरणा सरसीरुहारु नायक चरणा सततमृत जन सङ्कटहरणा सततमृत जन सङ्कटहरणा परमकृपा सागरा परमकृपा सागरा परमकृपा सागर वरसुकुणा पालित जन गो पालदासनुत पालित जन गोपाल दासनुत विनायका निन्नु विना ब्रोचुटకు వేరెవరు విఘ్నరాజ వినాయకా
Thank you very much, ma'am. Now I request our beloved director, NIOT, to deliver the welcome address and provide us an overview of the workshop and its expected outcomes. Please, sir.
Chief guest of today's function, Dr. Anumant Rao, Director General Samir, Society for Microwave Electronics Engineering and Research, Mumbai. My dear colleagues on the dais, of the dais, invited participants, guest speakers, and our beloved, my predecessor, Dr. Ramadas. Thank you for coming. Dr. Tata Sudhagar, ex-colleague. Very good morning to all of you. First of all, I would like to welcome those who are those who have been invited and those who have been associated with us from outside this institute, this wonderful campus. As you all aware, in the history of NIOT, it's actually the most happening time. It's all initiated by my predecessors, and we have the momentum now to do at least a couple of mission mode projects. Although we are very good in the operational mode projects, but I think the mission mode brings us the kind of momentum that it also require a lot of enthusiastic involvement of the senior colleagues and younger colleagues and so on. After I took charge, I think I understand that the commitment made by our institute to the Research Advisory Council that we should be holding a workshop of this kind, where the purpose of the brainstorming would predominantly be to deciding and also to prioritizing the kind of technological development required in-house, indigenous in the country for the oceanographic applications. I think we also would be aware the need of the sensor and associated electronic system development, especially in ocean engineering field. And this comes from the requirement of the in situ measurements in first place. They are the predominant users, and we need to collect the data in middle of nowhere, especially the deep oceans I'm talking about. And these data basically are the backbone of any mathematical modeling that we use to predict or forecast the weather conditions of tomorrow. In case if we are wondering how our sister organizations like Indian Meteorological Department is projecting the weather conditions of tomorrow, and you could see that in newspapers in case if you follow the physical mode of newspapers or even in the news clips, that they basically take numerical weather forecasting, the computerized programs that can actually give forecasting of tomorrow's weather. And all of these models are built on top of set of equations, and without the help of in situ measurements, they cannot be trusted at all. So I've been insisting and emphasizing in every other forum that the in situ measurement system has to be expanded what it is today, and it is, in my opinion, is still insufficient to claim that our models can really be predicting accurately the accurate predictions. It's not just only the open ocean measurement, but also on land, hinterland measurements too. But then we, being the National Institute of Ocean Technology, that we focus, our focus is more on the open ocean measurements. And when we try to address our research advisory council's suggestions to hold this kind of workshop, I first of all would like to identify who is the immediate user who would be benefited of this program. Then we thought it would be ocean observation systems. They are the immediate users within the campus. And then obviously it is the ocean sensor. It begins from the sensor and then the electronics and integration systems. Next. And very interestingly, all three of them, the group heads of all these three individual verticals, virtual verticals of our campus, they came together to my office. That shows how committed we are actually within the campus, first of all. So I have my colleague Arul, Muthukumarvel, and also Shankarji all on board of this program. And this program is an example of how the teamwork can also accomplish what the council has actually recommended to us. I would like to thank all three of them and also their team to bring this workshop in, to the reality and so on. So the sensor, it begins with sensor. It's not just only the measurement that I've been talking about. I think there's only one example. We talk about the underwater coastal surveillance. It's also very important, aspect for the strategic reasons. Our colleagues have been working, and there are huge amount of efforts have already been successfully made in this campus, very campus. In addition to that, the mission mode programs like Deep Ocean Mission, under which we are actually building a human submersible, has brought out lot of gray areas that we probably may not have realized. I would not say forgotten or neglected, but I probably did not have realized. So these kind of mission mode projects have given us the areas where we should also be start looking at very seriously in future. So maybe some of you may be already aware that one of the key communication that happens between the man who are actually put in a huge shell sent to 6,000 meters of water depth and to the mothership happens wirelessly. And we are talking about underwater communication here. And we are talking about 6 kilometers of cableless underwater communication here. It's not something that we would be seeing or coming across every day. And that obviously require a great amount of effort to design, develop, and probably you may have to demonstrate, and then you can actually deliver to the society at the country. It wasn't really required for us until that point of time. Now it is actually asking us to go ahead. And thanks to our sincere efforts of our scientists in house, we already made a wonderful underwater telephone communication for the 500-meter rated communication has already been demonstrated, and we are marching towards 2000 meters and beyond. This is one example I would like to tell you that there are technologies which has not been realized by us. Now it is actually time for us to realize, not just realize, but also to work on the design and development as well. There are multiple number of such kind of sensors, integrated electronic systems put together, and then their utilization subsequently in the actual field of practice, in oceanographic practice. So this workshop, I strongly believe, will deliberate, discuss, and bring out some kind of a white paper on what are the areas which are immediately required for us to be identifying as the priority basis. And I think we also aware of the fact that some of the sensors, although majority of them are actually slowly become indigenous and in-house, but then some of the sensors being imported, and there is a large amount of dependency on the outside countries, OEM and all that. So it's a tough task actually to negotiate those, and probably this workshop will bring out the list of prioritized technology to be taken up by our scientists, not just of this present generation but also the upcoming generations, to look at very critically and be indigenous, and to reach the Atmanirbhar. We talk about the self-reliance over the time. I think unless we make steps towards that, maybe the dream of self reliance may not actually happen. So, but I strongly believe that this workshop will kickstart the interest in identifying the technology to be developed in house, especially for the oceanographic applications predominantly, and that will actually be a great service to the nation. I also take this opportunity to welcome those who have come from outside of this institute to take your time around to take your time to go around our campus. We have wonderful facilities, acoustic test facility, and we have electronics lab, we have sensor development lab. We also have a beautiful integration facility for the ocean observation systems and all other laboratory. You may not be able to see our Matsya 6000 at the moment. She's not here anymore, at least for time being. In case if you are interested in visiting other labs, let us know through our colleagues. Maybe they'll take you around. And it's a beautiful campus inside the middle of the city. Maybe very exciting to you to watch the kind of science that we do on everyday basis. With that quick note, I really thank you very much for assembling here for this one-day workshop on oceanographic sensors and system development. Let this event be a great success and new beginning. Thank you so much.
Thank you, sir, for your insightful words and highlighting the importance of the workshop. It is now my pleasure to invite Sri M. Arul Mutaya, Group Head Ocean Observation Systems, to introduce our esteemed chief guest, Dr. P. Hanumantarao.
A very good morning to all, one and all present here. So it is my honor to introduce our chief guest today, Dr. Hanumantarao, DG Samir. So he has been working in Samir for the past 32 years after a brief stay in SAC Ahmedabad. He is actively involved in the implementation of various future-driven next-generation technologies for both strategic and societal applications for defense like DRDO, MIT, and Department of Telecommunications. He has been part of multi-institutional collaborative research towards the development of indigenous 5G solutions. He was part of 5G team and demonstrated for the first time in India a fully functional MIMO and massive MIMO systems at sub 6G band and integrated wave-phased array antennas. He was instrumental in building indigenous technologies, R&D facilities, and executed various strategic projects to address the denied technologies to India. He actively participates in developing Indian standards of 5G and represented India in ITU global meetings. He contributed towards SOC, SOP, and implemented electromagnetic band gaps (EBG) and metamaterial configurations in collaboration with Georgia Technology, Atlanta, USA. His current research areas include 6G solutions, intelligent reflecting surfaces, UAV detection and deactivation, spectrum studies, and RF SOC. He received his PhD from Queen's University, Belfast, UK, MS from BITS Pilani, and BTech from SU University, India. He has more than 34 years of experience in R&D in RF microwaves and MA wave technologies for strategic and civilian sectors. We welcome you for this workshop, sir. Thank you.
Thank you very much, sir, for introducing the chief guest. We are privileged to have Dr. P. Hanumantarao, Director General Samir Mumbai, as our chief guest today. Before delivering his keynote presentation, sir would like to share a few words with all of us in the presence of the esteemed dignitaries on the dais. The stage is yours, sir, please.
Good morning. It's a pleasure to be here. It's not my first visit, probably third or fourth visit. It was maybe last decade I was here when I was working at Summit Chennai. Now I moved to Bombay. So I was sharing few thoughts with the director and some of my colleagues at IIT Madras. So I teach at IIT Madras also. The way we approach the entire research there, as per the organizations are concerned, there is going to be a quite shift has to happen. If at all, what are we keep telling that it's going to be indigenization or maybe Atmanirbhar or self-reliance, it's been talked more than been realized, except a few of the brilliant faculties from IITs having their startups and doing. But as an organizations, most of the funding comes to the government organizations like you, like us, and we have large amount of the manpower. But when it comes to the implementation and substituting the systems which have been imported, there's going to be huge amount of the gap. So that probably we started addressing it. So the way we looked at it, maybe I just want to share these things more useful for the, I mean, as director mentioned, that how to take this workshop to a logical conclusion and identifying the areas and the topics what we want to work. I will go one step ahead, how to create a collaboration and ensure that that becomes a program. If you do yourself in the lab, it becomes a project. Maybe work with other, maybe few more colleagues, it becomes a bigger project. Unless you create a collaborative research, then only it's going to be a program and it sustains for longer. So that at least your goals can be much bigger and scope can be large. A few of the areas which probably I was discussing and mentioning them, the HF radar, which is still being imported in the country, which is all I can say that it can be done much easy way, much simpler way which can be done, because we have done much complex systems which gone on to the tracking the missiles and the satellites, especially for the communication with the satellites. These are radars are not that complex, but somehow we get into notion of not building in house. That's one thing really pains us when you see the amount of the manpower we have, amount of the expertise we have across organizations. So I always used to tell whenever we meet there, we used to have that what we call Chintan Shibir, what we call from the ministers, and we'd sit there and discuss that what we should be looking at in next 10 years down the line. At 2047, we're talking about Viksit Bharat. So we always say that whenever you want a solution, people say that every Indian will say that multiple places. Say that, oh, we have solution, we have done it. But as an India, we never show that as a solution. And a simple example, like take into the communication. We don't have a lab like in Ericsson. We don't have a lab like Nokia. We don't lab like Bell Labs or JPL. But we have multiple labs. But as a complete solution, we don't deliver anything. Still, it is distributed across the multiple startups and multiple MSMEs. So slowly that things, I mean, that approach has been changing. It's completely, there's a shift or a drift rather in that. So industry started coming to the organizations. We also changed our style of working. We are taking multiple institutes on board, and we try to build the systems as a joint collaborative work, jointly funded by them or funded by the government. So that has given a huge amount of the impact how we look at the solution. Yeah, like multiple domains in terms of that. We have been only on the strategic. Most of the work has been only strategic, except for the last maybe 5 6 years we've been working on the domestic and civilian applications. We took one simple example, like in airport. So every subsystem and the system in airport is not built in India. There are only few people in the world who completely capture it. And it applies to oceanography also, the sensors. Most of things, it could be submerged sensors or the surface sensors, except the satellite sensors which have been built by us, mostly for ISRO, from ISRO. There's like huge amount of the scope to do a collaborative research to build them. Then we went back. There's a one platform. Probably I just request, maybe I request most of the researchers here also. As an individual, also you can register there, or as an institution you can register. It's called Manthan. It's from the Principal Scientific Advisor. It's a PSA office. So that platform connects the requirements and the researchers or solution providers and people who can deploy it. So industry members are there, and we also members, and many made AITs faculties are members. So PSA identifies the technologies which need to be indigenized. If they are not completely equipped with that, or they are not become completely aware of it, what may be done, or maybe the director, or maybe the within MOAs, maybe secretary can mention that these are the areas need to be identified. I mean, there is no commitment from anybody. So PSA advertises all these things in the Manthan platform. These are the technologies to be indigenized. But advantage, what happens is once they have been advertised, if they're within the Manthan platform, the Make India clause comes into the procurement. When it has to be deployed in the country, automatically they say the technology is already been identified by PSA and they have been built in the country, and the preference has to come to the Indian solution. So that's only the way to penetrate to say that we have our solutions. So we took the airport authority. I mean, airports are one solution. There are 100 plus technologies have been identified to be indigenized. So industry is on board. It's a similar thing, probably, way we can say that all the sensors what we need to develop there, maybe the data processing or maybe the, I mean, though see, as an operation side, nobody can comparable with what NIOT does, but not on the complete technology development side. There's kind of a, we need a big leap required in building complete homegrown technologies. So we can identify these technologies. People can come to you. You can create the joint projects. Or somebody can have a solution they can give to you. Or with the Indian solution, automatically they get the preference. So this is the one area what I thought probably brings up a complete picture into how to build indigenous solution. That's my first thought. What we should do as per this conference is concerned. End of the conference, at least we have the faculty from multiple institutes there, and we have guests across the country. So probably you can think how to create a kind of a larger program with your senior colleagues and ex-colleagues of NIOT who has seen NIOT growing. So they can tell you that what was missing, and still if it's missing, then we need to go ahead and start doing it. It's one thing. And second thought, what we had most of the time, the radars are not being extensively used. What's supposed to be used for the oceanography. They have limitations, I understand, because you have the long ranges with the vast sea. But there are multiple ways to apply radars. Some from the spaceborne solutions, and some of my presentation I'll show that how we start operating them. Not for this application, but the drone-based solutions. How to create the ad hoc network then and there itself. Most of the time, we have the way I went through. It's not my domain or it's not my expertise of. The oceanography, but I was just going through how to connect work what we do. If at all any of our work can be of any use to build indigenous solution. So we try to connect the dots there, what we do and what is required and what can be done. So considering those three things, we looked at what can be done, not only us as an ISRO and DRDO, where we work very closely. We said like we have so much of technology lies with both remote sensing and the radars, and we have the radiometers, the scatterometers, and the multiple optical sensors there, IR sensors on the satellite for the remote sensing. There is something, the kind of the vastness what we have, the number of sensors what we deploy. See the multiple global programs. You have agro there, and then you have the multiple the what we call global drifting program there, and the drifters program. There's so many has been done. There's nothing, not a single program can capture entire thing what you wanted to do if you want to really study the ocean. So that kind of the vastness we have. Considering that, there should be some kind of better way to look at it. We have our own dedicated, the places where, think of Japanese people, they know their problem. They're very clear. It's a small country and they have their ocean around, their tsunamis and hurricanes. So their entire thing, they start looking from the seabed. They have their research starts from there. So they're very, very, very critical on that side. But our thing is we have such a large coastline and we have so much to, prediction is so much required. So those are the places where radars becomes very handy. That's what my personal perception is there. So the radar technologies, it could be on the coastal side or maybe the satellite based or UAV based. Not on a drone is too small to handle it. Maybe UAV based unmanned air vehicles there. Not just to as the sensor. Sensors, of course, remote sensing satellites do. Most of the time, the data what has been picked up by the sensors, what are being deployed. Fundamentally, I was going through the limitations of this. One is how long it can hold the data because you don't have the memory, and how long it can survive on its own. Of course, you have the solar powered ones and battery powered ones and so many things, but everything has a life. Can you extend it if you can dump the data? If we, the way we look at here, a UAV goes around, picks up the data, and it gets to 0, 0 and start collecting the next gen thing. That way, you can have a larger program which we have been so that it can be localized and still it can be global in nature. So that could the approach probably can open up different kind of perception to how to get the more accurate data. So you cannot cover the entire sea across the globe. It's going to be next to impossible. Whatever you do is still you have limitations. What are the data collected? It is function of many, many, many parameters. One of the latest development, probably this one thing I'll share and probably maybe I'll get back to my presentation later. There's a terahertz is coming up in a big way. Terahertz is coming in a big way. That's why I want to present what we do on terahertz in 6G also. Terahertz advantage is you're talking to such a high frequency. That's if not as difficult as a photonics. I mean optics. It's between higher millimeter waves and below actual terahertz. We're not going to the in terms of the lasers and the photonic side. We're talking about 300 gigahertz and sub terahertz rather. Chinese have launched some of the. I mean the way the news items come there, they're able to sense the ripples on the sea, seeing that some motion under the sea because the micro Dopplers are so tiny, which cannot be predicted by any other frequencies. Because we've gone to higher frequencies in terahertz, the lambdas are very, very smaller. So micro Doppler can be very, very precisely can be measured. But it's still a challenge. It's kind of a huge mathematical problem. C itself has is not a not a complete. It's kind of a mirror or a stationary thing. There's so much of disturbance happens. On top of it, any tiny disturbance under the sea can be monitored using the terahertz systems, reserves. What do you call it? The receivers. They went one step ahead, did the cryogenic electronics so that the receiver sensitivities can be increased very well. I mean, they give it very high sensitive receivers. So signal reflected back from the sea surface will be very, very small, very, very small. And you're talking about terahertz losses are very, very high from 300 gigahertz plus there. So that's kind of another area which is coming in a big way. So it's been the cryogenic thing in terms of the sensors. These are the few areas probably I have simple thoughts. Probably I'll be available there during the break time. We can discuss there and very open for the collaboration. So we like to take it for any of our expertise. We have more than 8 centers across the country. We have like almost 4 decades plus expertise and few thousands of man years of research been captured. And certain things what we do, we only do, and there are 2 or 3 more people do in the world. That kind of research we have there, and these systems deployed across the nation. So we'll be very open for the discussion during break. Maybe so again, it's a pleasure to be here and just want to interact with most of the people. We come from the other side, not on the usage of the sensor side, more on the building the technology. We want to map it. This technology can be made, anything can be reconfigured for the applications. I mean, submerged is a kind of a little bit of challenge there. At least over the surface and above the surface could be will be of some use our research and our technologies. So once again, it's a pleasure to be here. Thanks for inviting me here. So thank you. Bye.
Thank you, sir, for your insightful remarks and highlighting the importance of collaboration, which is the central theme of the workshop. May I now request For the keynote presentation, I kindly request the dignitaries to take their seats among the audience so that stage will be ready for the presentation while Dr. P. Hanumantarao delivers keynote address. Thank you very much.
Fine. Good morning. So its topic is census for oceanography applications. It's before not too much of probably I've been knowing less than what you people know, but I want to say what we have done so that can be made sense to the census. That's why I looked at it. So I take it through what we do, then kind of the activities, the way our presence in multiple domains, both on civilian side and strategic side. Then some of the census, the way I looked at it, what has been happening across the globe. Probably you'll have more information. I may be limited with my knowledge about the typically for the oceanographic applications. Then a space-based census, what are the best what we have in the country and where we can go further. Then what we are doing there in the 5G and 6G, which can be tailor-made. Some of the technologies of 5G and 6G can be used for the oceanographic applications. Because everybody talks AI and ML, so like that now it's a 5G and 6G is a buzzword. Everybody can use them everywhere. So it's basically the wireless connectivity. So we were born in 1984. So we were born for a very specific purpose. So there was a problem there during the Chinese war. We have the China war there. We're supposed to create some of the strategic micro components for operational radars. That's why we're born out of TFR. A small group within TFR started doing the research on the micro components, and it was called a strategic micro unit. Then that was commissioned as Society for Applied Microwave Electronic Engineering Research. We do applied research complete on microwaves, RF, and millimeter wave. Now we move to terahertz also. It was started in 1984. Most of the work happens on societal applications there, and we have three more centers there within Bombay. Of course, one center, three labs. One lab sitting in ID Bombay. We have 7+ acres of land. Then we are around 50 kilometers away from main campus. We have at Navi Mumbai campus. We have very specialized work. What we do for the non-destructive testing of the most of the airborne vehicles. Probably we're only the people do in the country. Most of the airborne vehicles, either for the strategic applications or the for space applications, they have been tested rather X-rayed. Radiography is done. We go up to 15 MeV. That's the kind of the energy is what we do. And we have another center at Chennai. It's next to again IIT Madras. We do a lot of work on the communication. Most of my work has been here before I moved to Calcutta. So we do the communication work, and the first lab in the country who does EMI/MC for the electronic equipments or components. And an average 500 plus industry get help. I mean, supported by us for improving their systems. We have one more center at Perangudi. It's much closer to this place. There we do research on 5G. And we have next center is formed in Samir, Calcutta. It's a very exclusive center, only center in the country, maybe only organization or only lab in the country. We can do something in millimeter wave, package it, and which is test flown in the most of the airborne missions, critical missions. So we work upper millimeter wave, 100 gigahertz, around 100 gigahertz. We design at MIC level. We go get it fabricated. The wafer come from UMS France. Then we package them in the waveguides. At that frequency, you don't have the connectors and the cables. It's only the waveguides going to the transmission lines. And we package it. We have the complete packaging facility end to end, starting from the wire bonding to the lithography to the testing of the wire bonds, on wafer testing, and on the chip testing. Then we package it. There's only lab in the country who can do the packaging of millimeter systems, and they're test flown on the most of the missions. There we're doing the 60 research. We have two centers. One more center is coming up at Rajarhat, where we're going to do exclusive research on the millimeter and terahertz technologies. One more center is again very exclusive center at Visakhapatnam. The only center in the country which does the IEMI, intentional EMI. Probably it leads to EMP, electromagnetic pulse, where future wars will be won, wars will be literally fought with the electromagnetic pulse. It's going to be we call high energy micro weapons. So we do research them, and we test most of the naval systems, the torpedoes, everything can they withstand IMI. So any IMI, it can be intentional, sometimes unintentional also. Entire network, what have been thought of, any electronics can be burnt. It doesn't exist anything. So it's going to be the kind of a hard kill. Hard kill. So it's electromagnetic pulse, large amount of the energy coming in such a very short time. It's kind of pulse and kills the entire it's burnt the electronics there. So it creates a large amount of the current. So that's research what happens at Visakhapatnam. We have one more center at Guwahati. That's again inside IIT Guwahati. We do the research on micro tubes and components. That's again a denied technology. Even today, every magnetron, klystron, which is used for whatever application, is imported. So we do research, and even the high power combiners, high power power dividers, high power loads. We're talking about the megawatts of the power. So all that work happens at our center at Guwahati. Okay. So we map the entire work into four. What we do for the nation, most of the defense systems where it can be mapped to an IoT or maybe the MOES itself. Name the radars, the antennas, and electromagnetics and RF. We have the expertise and all the tested and deployed across the nation, multiple critical missions. So I don't want to talk more about it because it's been, I think, webcasted. So I don't want to talk anything on that side. Societal solutions. Your ministry is very closely connected to Samir, not an IoT per se. MOES, we have the IMD. Almost every indigenous system built for IMD is built by us, starting from the MST radar, which has gone to ISRO first in maybe 1990. After that, ST radars, radiometers, sodars. Then we have the theodolites, and like you name it, large amount of installations which are designed, developed by Samir. And IMD has been completely handholding is almost for more than 3 to 3.5 decades. We've been part and parcel of MOS. Then we do other works at Samir Bombay. We do on health. We are building indigenous MRI. So bring the cost of the medical treatment, medical diagnostics to be affordable level. So by end of December, we'll be launching fully indigenous MRI. The magnet is built at Inter-University Accelerator Center. Again, it's a collaborative work and is 44 kilometers of 40 plus kilometers of length of the wire was wound on a 600 board dia bobbin and put them into cryogenic state. You understand like why it has to go to cryogenic state, superconducting state, because you have such a length of the wire, you start sending the current to create the electromagnetic field. It's basically electromagnet at 1.5 Tesla. So amount of the heat it generates and the power loss. So you bring them into the superconducting stage. So where your resistance is zero, and at that point you get them into the typically magnet is ramped up and we leave it there. You can remove the power supply, the electromagnetic field remains in place, but some portion of that is kept in dipped in helium, around 2000 liters of helium. So helium starts evaporating, then we have the what called zero boiling off. We'll condense them, comes down, so you can keep the entire magnet continues to be there. And all electronics are already built. Signal processing and image processing is done by the multiple doctors. AIMS directors are part of the steering committees. CDAC is our sister concern, does a lot of imaging. Then have multiple institutes across the globe been part of the entire mission mode program that. So by December, we'll be launching first MRI in the country. Then we have another for the treatment. We have the cancer treatment, probably leaving two more people in the world. And we built the radiation therapy mission. It's called linear accelerator and is installed even at Adair Cancer Institute. So we can tell it can give the indication that how effective the system. More than almost 1.2 million doses are given to the patients. And we installed 5 hospitals there. It's completely indigenous solution. And 2 or 3 more people making the world, leaving the Chinese counterparts there. So we have the Siemens and Electra, maybe something Varian also taken out from there. Yeah, we keep taking one company to other company. So that is another flagship program of Samir Bombay, leaving to all the atmospheric instrumentation. Then we have center sitting at, as I said, most of the EMI, EMC, IC packaging, EMP complaints, thermal analysis happens there at all the centers there. Most of 5G, 6G, some work happens at Chennai and some happens at Calcutta. And we do work at photonics, specifically for packaging of the lasers and creating what you call as TOSA, transmitter optical assemblies there and receiver optical assemblies. That the research happens at Bombay. So these are some of the recent activities. Every Vande Bharat train is tested by us before it gets onto the track. We test for the MIMC so that a patient having a kind of any implanted devices, we ensure that the radiation coming from the amount of the electronics what you have in the present trains, next generation trains, huge amount of electronics, there's a possibility of leakage of signal, electromagnetic signal, which can interfere with the multiple. It could be implants or some other system. I mean, there could be anything be on the platform, on the train. Train is in motion. Train is stationary. We do all the tests. We do the each type new Vande Bharat trains or any latest trains. It could be metro rail, or it could be the Vande Bharat train, or it could be the monorails. Any of the new thing, new technology which is coming up, which has a large amount of electronics embedded inside the maybe the entire train, basically from the engine. We do the test, validate, then only it gets onto the track. So that's kind of our flagship program of Samir Bombay. And this ST radar, as I said, for the atmospheric studies, is a full-fledged phased array, completely digital phased array, deployed at Gauhati University. Then this, what I said, for the cancer treatment, linear accelerator. Then we are the people leading 6G. So we had the honor of first project being launched by Honorable Prime Minister, along with ITU started the center at Delhi. On that day, it was launched, and we lead the entire 6G test bed. Last India Mobile Congress, October, we demonstrated 6.4 gigabits per second data. That's one of the largest data transmitted over air and operating at 270 gigahertz. We created the wireless link at 270 gigahertz. IT Madras and Summit, we worked together on that. And of course, there are the multiple solutions which we built for different industry. This I'll skip it. This is what we talked about, the complete end-to-end 5G. As I said, Ericsson, Nokia, Samsung, Huawei. Leaving that, nobody has end-to-end solution. We are the people have the complete stack. IT Madras, Samir, and IT Kanpur. Together, we build the entire solution and we transfer the technologies to Tatas. So, in 12 crores, only one frequency on the what we call a sub 6 gigahertz. And this is the first tiled array built in the country. And this we built part of the 5G, and we're more or less transfer this knowledge to DRDO to build the next generation radars. Entire radar can be built into a PCB now. So, of course, previously we didn't have the access to these ICs. Now we have the access to these ICs. For the radars, we don't use the simple IC. We'll have the extra front-end module so that we get the range. But the beauty here is entire thing is in a single PCB. The digital, analog, mixed signal systems, and the FPGAs complete the beamforming and comparing the entire data which is coming from the target, identifying the target. The entire thing can be done on a single PCB. Otherwise, it should be large. You better seen radars of very bulky ones. So that is kind of a next generation systems which are going to change the way the radars are going to look in the country. Of course, we had an opportunity to showcase to our entire technology, Honorable Prime Minister. This is the first 5G phone call made before 5G launched in the country. So it's again at IIT Madras. So is my boss. So we come under the same ministry, and we had India Mobile Congress 2022. We showed the first 6G, what we call as intelligent drifting surfaces. Whenever the frequencies goes up, the signal will not pass to the building, so you have to go around the building. So what we do is we bend the signal, it falls on the surfaces. We configure the surface such a way that beam gets steered to the user. And we created a different approach up to 5G, up to 4G. We have been the followers. 5G we started building. 6G we wanted to lead. We created something called Para 6G Alliance. 14 of us are members, founding members, mostly driven by the industry. Then we have released the vision document, which is agreed. Some of the part of the vision document has been agreed into ITU as the future 6G solution. Then, as I said, we started the project, first project. You can play that.
This goal, the two proposals which are approved today,
The two, one is at
the
IIT
IIT
Madras,
Madras Advanced Optical
that
Communication
is done in
Test Bed
optics. We do on
and
microwaves.
the Samir Advanced 60 terahertz test bed. These two will play a very big role because this is where all the IPRs, whatever technologies, whatever developments we do, they will. This goal,
You know what trouble we have? We don't get the people to work. We don't get a lot of people there for the RF and microwaves. That's kind of a huge trouble we are having. Even the permanent post, we are not able to fill it up. So that's why I just requesting you the faculty here so that we can do collaborative work. Your PhD students can be placed on us, and we can pay them even the internship for them. They can stay with us 6 months. We have an accommodation there. They have access to all the labs. Entire fab can be taken by us. So we need to think little different ways so that we can join hands to build solution. Then we deployed the entire 5G solution. We deployed at MCT MOV. Is a standalone system. We don't need an operator from the no, I mean Airtel or a Jio or my Vodafone. It's a complete our solution. Even the phones are taken from outside. Otherwise, end-to-end stack is ours. We had an opportunity to meet Chief of Army. We explained them how to modernize Indian Army with the 5G solution. Of course, our 6G solutions, we already built the 270 gigahertz wireless link, 140 gigahertz wireless links. Why I'm talking these frequencies, especially we want to do the precipitation radars. They are going to work on those frequencies, 300 gigahertz plus It's going to the future. Probably it comes under oceanography or a Minister of Earth Sciences or comes from ISRO. That's the place where the research is heading there. Most of the radars to be built there for rain precipitation is going to be at 300 gigahertz plus. So that's why these research, the components what we built, going to be very useful. We already built indigenously the filters, the antennas are built, waveguide components. I'm talking about 300 gigahertz and 170 gigahertz built within our own office. We have the facility. The waveguide dimensions are 1.7 mm, 1.7 mm by zero point 0.8 mm. That's the waveguide dimension. That's the frequency. That's the kind of the dimensions we handle with. And of course, change of guard. We have new minister there. He was there in IT Madras. We showed our 5G solutions. Then we went one step ahead. That's what I was telling them with the director also. We need to be a little more aggressive there. When we started going back to the user, we went to the army and said that we have these technologies built across the country. Why can't we leverage it for your solutions instead of directly? You said, do you have a solution you want to buy? It's not going to be practical. Instead, we take that at least 3 years down the line, we know the specifications of Indian Army or Navy. We start building a solution for them. So we signed an MOU. That's kind of a landmark thing. And we try to do a complete magnet where you can, when the soldier gets into the field, the battlefield, you don't have a network there. This manpack can become a 5G network. We can create an ad hoc network then and there itself. And the same thing I want to visualize it. It can be built for the ocean sensors also. Which only thing is it can be motion. It need not be in motion. It can be static. Both can be implemented there. Then we want to do typically in the defense bands. Then convoy communication when long convoy is traveling there along the borders. How to get the connectivity using millimeter technologies, then non-terrestrial networks, that's what I'm talking about, the drone-based solutions, satellite-based solutions. It could be low Earth orbits or medium Earth orbits. You can play that. It's going to be look like, visualize it. How the base station gets onto the drone. You can create multiple drones, create the network, and you get the large amount of data. The difference is you are building the 5G itself on the UAV or a drone. Then you have the connectivity. This is what I'm visualizing it. You have the satellites on the surface of the sea, on the land. What we call as a 3D integration. The land, or maybe soil, sea, water, or the sky. So we need to combine all the three and create a kind of a network. And of course, the strategic applications. I have the terahertz imaging. We can see what is inside the structures. A similar thing we started doing for the Navy. Then one thing which is still pending in the country is we don't have the integrated mass. Only recently we are trying to get one from Japan. I know. I mean, how many thousands of crores been built. Basically, all the sensors will get onto the single mast. All the radars, surveillance radars, and IFF things, and probably the other EW systems. Every gets into one mast. Otherwise, you'll have multiple masts like that. That will be the future is having a single mast on the ship, and we'll have the seamless communication for each band and each application. So the one of the most advanced one is from Japanese people. It's called Unicorn. India is procuring that. We are proposing that we should be building that. And every warship, at least 9 or 10 warships in the country, we have our system what you call as Kavach, which is deployed for the receiving the incoming missiles by throwing a aluminum shaft, so that incoming missile get little deceived there because it finds the large target in the sky than on the sea. So that's one of the work which is being successfully done and deployed in multiple missions. Coming back, that's basically what we do. Then I come back to 6G. From there, that's what we do in nutshell. Because we have very little time there, probably. Run through. Only thing what I had, my only observation was typically the static ones. Most of the things are static, though we make the drifting sensors, but still I consider them not largely been covering the entire surface. So we need to have, as I mentioned there in the previous talk for 5 minutes, mentioned that we need to have creating a multi-nodes, dynamic, and long-term modalities. These are the three things which are going to drive, if at all you want to have a complete idea on the mapping of the sea, above the sea or under the sea. So these are the things which we need to be very, very critical. See, the implementation technologies can be many, but the approach to that one is you're thinking of a larger programs. You think that is identify these many square kilomiles, whatever you want to do it, but implement a solution which is absolutely, I cannot say completely foolproof until the extent possible, that reliability is very, very high, and it demonstrated, then that can be multiplied. That can be considered as a node. The way I visualize it, instead of putting one sensor, you take a large amount of the area and create a kind of a solution. Initially, that becomes a phase one of the program. Then that becomes a node. Then I can create multiples of such systems across the ocean of whatever interest. Then it becomes a multi-node solution which can be connected there. But I know it's been done with a independent sensors. I'm thinking much bigger way. So consider as a area itself as a node. What we basically, the way we reflect them into the radars, synthetic aperture radar. We don't have such a large surface, large aperture there on the aircraft or maybe the satellite, but synthetically we simulate the entire surface, each reflected signal from the ground or from the ocean, and that becomes one element pattern. We synthesize them, do the signal processing. If the aircraft moves a mile or maybe a kilometer, and length of my antenna will be 1 kilometer, which is not practical, not going to practical. So that's kind of the approach we want to implement there as a larger program, which will be more than happy to work with you people. In the typical things, we know them. The way we always say that the data what is collected, I'm not completely sure that how independent of the, see, it does its own data because it has a typical sensors. Of course, most of the things are known to you. Whether it is taking the remaining environmental impacts on top of it, is it adaptable? So is it correcting the data? Because you get the data which is collected long, long ago, it has been picked up by you and start analyzing it, but you don't know the actual C scenario at the time or the environment there. Is it adaptive? So there can be, I don't know how the sensors been deployed completely there. Can these sensors can be made adaptable with the environment, or environment data is also stamped as the way we get the GPS coordinates, at that coordinates can get the entire parameters. When the actual data is collected, it comes with along with the stamping of the data, the environment. Then probably I have my models can be more effective than just the data collected months back and analyzing today, not knowing what are the sea condition that day. Unless I have multiple other sensors to tell that at that instant, definitely you're not time synchronized. The data is collected on the sensor location and the actual scenario there. That's one thing which I keep reading there and saw that there are places where we keep missing the data. So that could be one other area which we can think about it. Of course, these are done in a large, the way I mentioned that multi-institutional things. You have the coastal dynamic experiment with the US side, then you have surface velocity program. They're like large programs, but still, it's again at the limited scope as per we are concerned there. So maybe we decided that we were going to work. See, entire thing happening in the ocean across the globe is one phenomena as a global phenomena, but localized phenomena for our own coast, how you tailor made the solution. So that's the other way to look at the, we can get the data from them, or you can use the models from them. See, always you take the, I don't know how many people know the propagation model of your base station which is deployed there for 4G or 3G 5G. It is not the model made there for Chennai city. Some model made somewhere implemented there, and the entire towers are been deployed, and it works, and you, but it doesn't work efficiently because your model is not tailor made. That is the difference. That's what I was looking at it there. Can that be a completely custom built for our requirements? Now, of course, these things, that what do you do, the global diff program there, you want the sea surface temperature there to validate with the satellite data. That's what I was mentioning. To get that kind of a correlation, though it's a different departments, the data is available to you because you're the people you know how to handle the data, and ISRO can give the data to you. So that, I mean, I know the ISRO closely works with an IoT whenever they put the transponders, because I come from SACAM, where these payloads are built. So I was talking to the senior people there. Recent Ocean 3 said they had the input from NIOT before the transponders are built. Payloads have been decided. So happy to hear that there's a kind of large amount of the collaboration happening from the sensors and the user. Typically, if you look at that, what we do, certain things which I'm trying to mix them to say that we build the first MST radar. I'm almost 40 years, still it's working there. Even today, the data is used for it's basically we do in the sky. It has to be translated or maybe reconfigured for the sea. It's for the MST radar meant for the observing the atmosphere. The data goes to SHAR before each launch. Then with the ST radar at 200 megahertz there, then wind profilers, multiple numbers there. Then you have the cloud radar working on the car band. Then the first radiometer built for the ground applications. Again, all this for IMD. Leaving the first one, which is meant is even today, or maybe at least when we installed, is the second largest radar built in the world. It is 1 square kilometer footprint, 1024 elements, and fully functional digital MST radar phased array. And we built in 1990. And that's kind of the challenge we had there. These are the multiple radars for the, as I said, we are very close. We closely work with MOES, especially for IMD. All these are meant for IMD applications. As I said, this leaving one meant for this room. Then we have ST radar. Then we have the cloud radar. Then radio theodolites. Then wind profilers. The multiple in numbers. Then we see the sodas across the country we deployed, and probably we need to get that one step into sonars. It becomes your military with application for oceanography. That's what I'm saying. The technology wise, we have an expertise. We need to reconfigure it. Then coming back to the satellite, the only thing what I looked at is the kind of the sensors what have been deployed there, the amount of the data, how frequent it's been. See, one is satellite itself using a sensor and collecting the data, but satellite also can be used if you can find a mechanism to transmit the entire data to the satellite. Satellite can retransmit it to other place also, because satellite can see the larger surface area than any other means of doing it. So that could be another what we call as the massive network, multinodal network. If we can create it, and satellite one of the transmitter can be used in the receiving mode. You find this data can be brought to a single node at what we call as on the ground we call an earth station, and upload it and probably transmit back to multiple places. Could be. I'm just visualizing it how it can be done. This is one of the latest one what where India stands. I think some of you may be aware of it. At least for the young people who are not really into, just jump into the satellite based sensors. OceanSat is the latest, as latest as November 22, is called the Earth Observing Satellite. But mostly, typically, these are the few payloads meant only for NIOT or maybe the oceanography. One is OceanSat Scatterometer. It's basically typical scatterometer, measures the scattering signals to identify measure the wind speeds and the vectors at the sea level. That's probably one of the most efficient way to do it in the satellite based solution there. Then we have, of course, ocean color monitor. It's a basically photonics based, optics based, camera based solutions there. You have 13 channels, medium to high resolution spectrometer. Again, it's the radiometer. It's a receiving signal. See, when you have the scatterometer, it's more of a radar. I send the signal, get back the scattered signal. You measure the wind velocity or maybe the wind speeds. When you have the radiometer, basically I'm collecting the data which is self-reflected from the surface or the environment there, and it is in photonics mode. This other one is sea surface temperature model system. This is a new one which is being deployed there, both on visible infrared imaging. It's a radiometer again. It works in conjunction with scatterometer. So they kind of combine the both payloads to get the data. The last one, it's not Indian system, it's I think a French system. It's called Argos. It's a very advanced data collection system. That's what exactly this entire data. I'll show the picture there, how the data is collected there. And that's simple platform. It's not even a payload. And that can be easily done. Anybody there in the country, the amount of the manpower what we have and the software expertise we have. This is a typical satellite on which all these payloads have gone. It was in November 22. It's, of course, the launch vehicle was PSLV. It's a polar sun synchronous orbit. Then the repeativity, that's the advantage here. Every 2 days, you get the data. Every 2 days, you get the data. So that's very frequent there. As I said, these are the 4 payloads which have gone on that. And generally, it crosses that 12 noon. That the day we get the data collected. See, all the data we can collect also we dump down to the one of the station for the processing. This is the first sensor, what I mentioned, ocean color monitor sensor. It has 13 channels and it's one of the most sophisticated sensor flown on the Indian satellites there. Of course, the typical scatterometer, an antenna working there in the Ku band, then surface monitor, temperature monitor system there. Then these are typical advanced data collection. It's nothing there is every data. It is with data collected from the the sensors floating there on the ships, or maybe come you have tagged some of the sea lions, or maybe some of the on the earth, on the land, and some of the transmitters which have been collected the data, some of the bios or whatever the data is available there on the sea or on the ground can be connected back on the satellite, and they created a platform what was advanced data collection system. It's basically in the receiving mode, collect the data and retransmits. Processing can be done on the floor on the ground. Scatterometers, the one which is flown is working in the Ku band. It has both the horizontal to horizontal, vertical to vertical. It has a swath of 48 kilometers, and on the HSVV and VV it has 40 and 2. You have a variable one. So high resolution mode for ocean surface, vectors of 12.5 kilometers for the first time in addition to 25, which was not there. Up to OceanSat 2, It was 25 kilometers. We improved the resolution by OceanSat 3, and we have an accuracy of approximately 1.5 meters per second, direction of 15 degrees. The one which could have been extended for the next generation systems will be the synthetic aperture radar, so that you can get the higher resolutions. Of course, this is a photonics based solution. This is the first radiometer built in the country, the complete radiometer on the dual band. It's basically, it measures both the water and the water content and the temperature. It works on two high bands. One is at Q band, other one is at 40 gigahertz, the V band also. So this is the first demonstration. Last week, your IMD DG was also there. We showed him there. And of course, MOS, your secretary knows this work has been done. And the recent IMD celebrated 150 years of his existence in the country. And Prime Minister said that go one step ahead. They're going to build a network of 25 radiometers across the country. So we're pitching in that. We have indigenous solution. We brought a industry on board so that they can build the solutions and deploy for IMD. And this is a complete system build. This is our expertise. So we can build a solution of a kind of, I mean, if it's not submerged one, is still we talk about the on the surface. Probably when you come to the underwater, it's kind of different kind of a beast on its own. It will come out. That where you know the expertise. So as a technology, we know things there. So these are completely in-house solution, starting from the transmitters, receivers, basically receiver. There's no transmitter in this, is a radiometer. It's a receiver, antenna. This is a plate which moves and into the sky and collects the data. And there's a lens antenna inside. Then from we have the noise source, again that is imported. So noise source has to be imported for which has a reference signal. And from there we convert it back into the data. Then altimeters, we are probably every of the mission there, airborne missions have used, starting from the Prithvi to the anti-missiles. We got the what you call interceptor missiles. We have all the altimeters have flown on the most of the missions. Now current our designs go up to 10 rupee coin footprint. That small we brought them, including the antenna. That's the kind of miniaturization what we have. This is the one which is similar to what we talk about HF radar, what we call a synthetic aperture radar. The first of its kind built in the country called ground-based synthetic aperture radar. We use it for coal mines. Whenever you have the open cast coal mines, if you see, they keep piling the entire called debris or whatever there, and you see lorries keep going there and piling up and up. But one small mistake, the entire thing collapsed into the open cast mine. Is going to be large amount of the lives are lost. That's typically what happens in the coal mines. So we came up with a radar which moves on a rail. Can you play that? That video plays. Yeah. This is basically, this generally happens on the space. The SAR synthetic aperture radar is the payload is taken on the antenna and the entire thing is taken on the airborne platform, mostly aircrafts or the satellites, then collect the data. So first time we built on the ground, we created a mechanism. The challenge was to make it work in the environment in the coal mine. That's got a very dusty environment. It works in a C band and it does at 400 meters in range, 600 meter azimuth, and we can get we do both XYZ, but they find any slight lateral displacement, we alert the coal mine saying that there's a possibility of the entire mass going to collapse. So there's the first of its demonstration in the country. Now they wanted to build a 5 or 6 of them and see that how effective it is there across the coal mines and network them. This is another large project, at least you are more aware of than me. Starting from up to 2020, it went there. Almost 4,000 plus floats are sitting there, Argo floats, array of real-time geostrophical oceanography. But it has again limitation. What are you see the spaces of the sensors? The floats are 3 by 3, basically with a 300 kilometer spatial resolution. It's not going to give much of data for you for analysis. This is what I said. Satellite, of course, is application of that. I mean, operation of that. Skip, probably you know it better. There's a place where probably we'll be more than happy to collaborate with the NIOT and all the researchers to build the radar-based solutions there. Can you do the detection by the sea sonde? It's been deployed at multiple places across the globe also. We can work on that. It's typically 3 to 30 megahertz HF radar, works in the FMCW mode. So it can be easily built. I mean, as per the technology and expertise what we have, I don't say it's. I mean, you can just go into the lab and bring it out, but it's very much doable. Very much doable. We're more than happy to associate with you to build that. Let's keep all this. This is going to the future. We're combining entire thing into a single network and kind of a satellite-based solution there. The data is available there, ocean observing, integrated system of everything instead of isolated systems. So we want to go one step ahead instead of having a stationary. How much more time I have, sir? Another 5 10 minutes. 5 minutes. I'll just try to close it. 5 minutes. I'll close it. So we have the typically we try to put up the most of the time is the stationary systems. We can go to one step ahead, do the phased arrays. So we can scan it. Instead of getting to the satellites, you can put the coast. I can scan it and still collect the data. That's much easier to, and it's much less expensive, and it's on the ground. So it's easy to easy to, I mean, operate it, maintain it. So that can be the one of the solution there. And we have the tremendous expertise in the phased arrays. We build the phased arrays for the multiple radar solutions there. We'll be more than happy to work with you. Typical type of phased arrays can be analog based phased arrays or digital beamforming or hybrid beamforming. Each has its own plus and minus. And we can scan the beam. We can have the multiple beams going in the multiple directions there. I can control the location of the beam. I can change the amplitude of the beam depending on the near object. I can get the reflections, and the farthest object I can put the more power. This is one of my PhD students algorithm. It's kind of a beautiful piece of work. We created this by simple means of creating multiple beams. It's not going the conventional way of doing the synthesis. We create the multiple beams, and playing with the multiple beams, we're able to generate this kind of an application, and we can shape the beams also. As I said, we can have simultaneously multiple beams. I can control the amplitude and the location of it also. And this is the beauty. A conventionally want to create a contour map using any satellite antenna. It's a large amount of the pattern synthesis done. Instead, we can take the multiple beams, we can map. And if you want some location not to get the signal, that also can be created by just controlling the particular beam and the direction. I can reduce the power. I can reduce minus 20 dB or minus 12 dB so that that area, specific area, will not get the signal. So this kind of contouring is also possible. This is one of our latest algorithm, one of my PhD student piece of work. It's a good amount of work out of them. Quickly, I run through in 3 4 minutes what 5G and 6G about it. So if you want to, I mean, probably it's only the luxury what you get when you have these technologies, the data. The amount of the data you can transmit because we have the bandwidth. The bandwidth which is available there, every generation gets 4x bandwidth, and the data also multiplies of that range. So you have the 4G, we have the 25 megahertz, then 5G, we have 100 megahertz. We expect to be 300 to 400 megahertz of bandwidth. Bandwidth is the reason, under the frequency bandwidth, that in turn reflects large into the data rate. So if we have one word you want to mention, what each generation can do, around 2010, we have the 4G, we call as connected people because suddenly you started seeing the internet getting onto the system. Then you have the 5G 2020, we have the connected things, we have IoTs, we have the vehicle to vehicle communication. Then the 6G going to be the connected intelligence. The device itself going to be more intelligent. It need not completely depend upon only on the base station or the we call as a remote reader head. It is becomes what we call as integrated communication and sensing. Your device itself is become a transceiver system for you. Even you make a phone call to the neighbor, it has to go to the tower and come back. Things going to change in the there's an intelligence going to be embedded on that. So 6G going to be more of a connected intelligence compared to the connected things there. If really one word, if you want to say that, if at all what you're seeing, the generation is coming not because of any of the technology, all these technologies existed there as per the military's consent and whatever we use. It was available there at the laptop or desktop level. The smartphone invention is the one which changed the entire thing is accessible. Every application what you see today, it was made possible more than the technology is implementation of the smartphone. If smartphone not there in your hand, none of these technologies are practical. It could be the UPI payment or other authentication or a bank thing, anything you name it. That is made practical only with a smartphone. Otherwise, these technologies should have lied down. At least it will not be this popular. What are the data you say? That used to be always connected with a Wi-Fi router. You don't go anything beyond. The minute smartphone came into the picture, things have changed. So that's why we always say more than the communication kind of a explosion what we have that was made possible and accessible with smartphone introduction of the smartphone than the technology per se. This is the advantage why people talk so much about 5G. Nobody talked about 4G was the entire same antenna can be reconfigured for the urban environment. You want the high rise buildings and you want to have the low rise buildings and long distance, intersite distance more than 1 kilometer. This can be reconfigured without changing antenna. That's the digital beamforming. That's one which made entire thing 5G was it becomes a fabric of the society. Where you want to deploy, it can be reconfigured for the deployment scenario, which was not practical in the 4G. 4G was more of a stationary beams. You're never able to steer the beams and never able to shape the beams. That is the luxury with the introduction of the MIMO. So I'll skip it. The two projects we are doing in 6G. One is at 140 gigahertz using intelligent reflecting surfaces. Then what we call as orbital angular momentum. There's one thing which I want to introduce to people. Most of the people heard of the polarization. You working with the sensors. You have the vertical polarization, horizontal polarization, right hand CP, left hand CP, and we have slant 45, minus 45. But you look at any of those things, you get one polarization diversity, or you can double the data sending it to both polarizations. That means we call them as a spin angular momentum. If you see the vector rotates in a circular, in a kind of a, if you have a circular polarization signal, it goes in a clockwise and anti-clockwise. If you see the phase friend, it's a circle. In orbital angular momentum, that also goes in a circle, but the entire wavefront is with a helical. Because it has a helical wavefront, you can have infinite modes. It's no longer a polarization of two vectors. No, I can have each orientation. I can create orthogonal modes, mode 0, mode 1, +1, minus 2, plus 2. We can have infinite number of modes. Each is orthogonal, they don't interfere. So that's one what we are implementing. We already built one of the solution there. We built an antenna and started testing also OM0, OM1, -1 also. And you can send the data on each mode so that you can multiply the data the way what we do in MIMO. Because you're talking about the higher frequencies, building a solution at that kind of frequency at 300 gigahertz using MIMO becomes much more complex. So we took the concept of OM. That physically you want to visualize it. If you stand on Earth is rotating over an axis, your motion on the Earth is always a circle. But with respect to Sun, when Earth is moving with a different orientation, that becomes helical. So that becomes if you on the Earth is a circular polarization and Earth going around the Sun and the plot that wavefront that is going to be the orbital angular momentum. That's the way to visualize it. I'll quickly skip through. This is what we do is it's not a phased array. Reflected signal can be controlled 0 and 1. Each color refers to it could be 0 reflected phase or 180 reflected phase. I can steer the beam. So we implemented that. We took an antenna, designed an antenna, loaded with the vectors. I can only change the voltage of the vector. I can control the amount of the reflected phase with 0, 90, 180, 270. Each color refers to one amount of the reflected phase of its 20 by 12 element array. If angle of incident is 30 degrees and you want to steer the beam to -20, that should be the wavefront on the array. And you see that completely we're able to steer the beam -22 +40 without having any phase shifter, just controlling the bias of the vector diode. So that's the uniqueness. That's what we call as IRS. Then as add A on that, identify the way the user, steer the beam user to the user. That becomes a completely AI driven IRS for the non-line of sight communication. So let's skip this. To visualize how OAM going to look like, that's the OAM mode 1. It propagates. Then you see the next mode 2 comes, the entire phase front is different. Then mode 2 propagates, mode 3 propagates. You combine them, you see each color is distinctly different. So they're orthogonal. So they don't interfere. They can travel in the same medium. And you can combine more of them and you can get the large amount of the data transmitted. We built a solution. We took the typically what we call a uniform circular array. We generate the mode 0, mode 1, mode 2, and we took another approach of creating what you call a spiral plate. You can see how the mode is moving. It's a mode 1. Then same thing we built in other modes also. So it will be maybe by this October we'll be deploying the entire OM based 6G wireless link. So my side, any quick questions if you want I can take. And that's the end of my presentation. Thank you. Thank you.
Thank you very much, sir. May I now please request our dignitaries to grace the dais for felicitation ceremony. Director NIOT, Group Head OE, Group Head MSS, Group Head OOS. And sir, you can also please grace the dais.
A quick question, I can take a couple of questions or we can discuss. Yes, sir. Please.
Sir, can,
Okay.
If there is no more question, let us thank the chief guest. Thank you, sir, for inspiring words and presentation and for sharing your vision with us and extending your hand of collaboration with us. As a token of our respect and gratitude, I request our beloved director, NIOT, to felicitate our chief guest with a shawl and memento. Thank you, sir. I now request Sri M. Sankar sir, Group Head Marine Sensor System, to felicitate our director, Professor R. Balaji, as a mark of appreciation for his leadership and contribution to ocean technology. Thank you very much, sir. To express our gratitude, I now invite my boss, Sri S. Muthukumar Will sir, Group Head Ocean Electronics, to deliver the vote of thanks.
Good morning to everyone present here and ex-director, my boss, Tata Swagar, and group heads of our NIOT. I am welcome. I thanks for coming here and gracing the function. It is my honor to privilege my proposed vote of thanks to on the occasion of the workshop, Oceanographic and sensors development. First and foremost, I extend my heartfelt gratitude to our extremely chief guest, Dr. P. Anumandarao, DG of Samir, for gracing this event and for giving inspiring speech for uh, uh, during this inaugural address. Sir, your words have truly set our tone for this workshop. And also, apart from this, you have given the wonderful presentation for about for a successful development. You have given the inspiring speech for collaboration work with NIOT as well as multi-mode sensor system for oceanographic system also. And your innovative speech will be definitely will pave the way for our sensor development as well as system development, sir. I also deeply grateful to our director for his warm welcome address as well as sharing his vision and roadmap for our workshop. The special thanks to our distinguished chief guests, speakers, and panelists who are coming over here, and leadership. And the leadership will guide us for advancing our indigenous sensor development and systems. Our special thanks to our organizing committee and entire team of our Ocean Electronics, OIS, as well as MSS for the full support for the past short time, only for the 2 weeks. And apart from this, I all the participants who have come here and expert speakers and students from the various universities and students who are doing the project in NIOT for gracing this for coming here and gracing the function. Thanks for all of you. This actually will not fruitful without thanking our four pillar of our NIOT, our accounts, finance and SNP and admin and estate, along with the CMC. So they given the within short period they given the support, and then this workshop made a grand success. Finally, I will thanks our transport section who have given the all the support for in sending the car as well as all the distinguished panelists and students to come over to pick up, and then and also they're going to drop it finally. And who are directly involved and indirectly involved in this function to grace a to grace a workshop in a grand success. Thank you, one and all.
Thank you very much, sir, for proposing the vote of thanks. Let us now stand for the national anthem. Thank you very much. With this, we conclude the inaugural session. All the dignitaries and participants are requested to proceed for a group photo in front of Sagar Sangamam. Following the group photo, we will have high tea at Manthan Hall.